Hi, this is Shuai Liang and sl5352 doing the probability and stochastic processing course in homework number 4, and the questions go into the number 2. The random variable x is a uniform interval -1 to 1. Find the gx, that is given a mapping of a y equals to gx, which then fy equals to e to the power of a minus y and times the u of y. So this question actually gives us the density function of fx and the density function of fy to find the mapping ways of these two random variables. So first things first, think about actually the connection between two fundamental, the functional connected random variables, which is in this case is x and y. So the fundamental theorems using the basic thinking is that there has in the same intervals of a mapping, they got a same probability. So first things first, we're gonna write the capital case of y, which is doing an integral here, and it's very easily calculated as 0 and 1 minus e to the power of minus y here. So we could probably here think about let the inverse g equals to g inverse y equals to phi y, and we write the probability here. It's very important. This line is very important to get a basic connection between these random variables. That is the probability of the y is less than lowercase y, which is used in capital case of a y, and that is in capital case of a y here, and it's equals to, when you change the capital Y to gx mapping weight, and gx is less than y, and here we just raising that x is less than phi y, which gives us a little bit condition that the gx is always continuous raising. Because gx is raising, that the continuous raising, and the y is the gx. Gx is mapping to x is mapping to gx, and y is mapping to the phi y. So that gave us a little bit clue about the going down. And the first thing is to talk about the condition that the gx is always rising, and another condition is gx always going down. So under the condition such that gx got always rising, which is in this one, and the probability of x is less than phi y could be raised as the integral here from an interval from -infinity to the phi y fx to integrate with x. That is can be right here. 0 goes from 0 to 1, and in an interval from phi y from -1 to 1 is 1 over 2 times phi y plus 1. And these formula can be right as a truly fx can be calculated here, which is the x minus x plus 1 over 2 when x is from -1 to the 1, which is a uniform, the kind of like a distribution function, or the cumulative probability. And when y is greater than 0, which means x is greater than -1, and thus gives us two kind of like a condition, as in g minus 1 equals to 0 and g1 equals to infinity. Yes, which is can be mappings. It's in figure out mapping ways of x minus 1 mapping to the beginning of a y, and x1 mapping to the end of a y. So it's like from 0 to infinity. And this time the the capital Fx is like 1 minus e to the power of minus gx when x is interval of minus 1 to the 1. And in that case, we could easily write that from from this formula here. This formula here, right? So 1 minus e to the power of minus gx equals to x plus 1 over 2. So we could solve the gx as minus ln of 1 minus x over 2. Now check these conditions here. The first condition, gx is always raising, which is true because when x go from lower to the bigger one, so minus x go from the going down, and the ln is going down, and the minus is going up. So it's raising, keep raising, and g minus 1 is equal to 0, which is true, and g1 is equal to infinity, so it's true. In this case, gx is equals to the minus ln of the 1 minus x over 2. So under the second condition, with gx is always going down, and the process is almost the same, but the only thing you need to change is that the x probability here is less than phi y. You need to change to the x is bigger than phi y, which gives us you calculate the probability here, so 1 minus capital Fx. And then it's still the same, that the 1 minus here, 1 minus e to the power of minus gx equals to 1 minus x plus 1 over 2. Then you calculate the same thing, that gx could be mapping as this one, the minus ln of the x plus 1 over 2, and check the conditions here. It's also correct. So all of the gx has two forms of existence, which is true because of fundamental theorems gives us if you calculate the derivative of x of the gx, which you need to use an absolute value, and this absolute value gives us the same one. So both are right. That is question 2. Thank you.